Gotham and the algebra students. Mr. Lawrence here, and today we are going to be talking about domain and range. Now, domain and range are real simple ideas, but a lot of times students get them confused. Domain is simply the input of an equation, function, or relation. It's your x values, your input. Remember when we did input output tables and you had 1, 2, 3, 4, 5 across the top? That would be your domain, the input, what's going into the equation. The range, the range is the output, what comes out of the function, or the y values, or what comes out of the equation. So we're going to be examining domain and range. We're going to do it a couple different ways. Let's get right down to it. The first way is you might have a set of ordered pairs, and they might ask you for the domain. Well, my domain in this problem would be all the x values. And so I see an x value there. I see a repeated x value. I'm not going to underline it because I'm not going to write it down twice. And I see an x value there. So my domain would be the set 3, 4. And you notice it's not a 0.34. I didn't use parentheses. It's a set. It's all the x values, 3 and 4. My range, on the other hand, would be the set of all the y values. Looks like I have a 5, 6, and a 7. So I'm going to write 5, 6, and 7. Oop, there's the bell, which means a lot of you lovely students are coming to see me. So I better pause this video for now. Hold on. Oh, oh, good thing. I thought I heard a blue bunny attack coming, but he's nowhere to be found at the moment. So I will talk to you in a little bit. Have a good morning. Okay, algebra students, I am back, and it's been a couple hours, so forgive me if I repeat myself, but I'm getting ready to do domain and range for the second set. So let me do my domain. Remember, my domain are my x values, and I don't repeat them. Now, one thing I do want to show you, it's usually customary to write them in ascending order from least to greatest. So -3 is the smallest, 6 is the next smallest, and then 7, next largest, excuse me, and then 10. Okay, and so there is my domain. Now, don't worry about making these braces. I think it's like a coordination thing. I used to have a hard time making them when I was your age too. Now I do them pretty good. Every now and then I screw one up. But, as long as you make the best effort, you'll get practice. I won't take off on it. You can't use parentheses though. You can't just use parentheses. I mean, if you absolutely had to, I guess I could let you get away with that. But you really need to kind of do the scoop like that. And the more you practice, um, the easier it'll get. I mean, you can think of it as a face. This is a forehead. That's the nose. That's the chin. And then this one's just looking the other way. Forehead, nose, and chin, if you wanted to. See? Okay. Anyway, so, oh, by the way, Gotham, my appointment for my manicure is set up for Monday. So just thought you might like to know. All right, now my range is going to be the negative numbers, or in this case, they're not always the negative numbers, but the y values, and they're all negative. And I'll start with the smallest one of -12, and then -10, and -5, and -2. Okay, that is one good way to express domain and range, and you'll be expected to know how to do that. Now, my favorite way to do domain and range is involving graphs. And what I like to do is I get the picture of the equation because it's going to want to know the domain and range of this equation. And I like to use, for the domain, I use a vertical line. And for my range, I use a horizontal line. Okay? And at first it might seem backwards, but if you think about it, domain is input or x's. Well, right here, what's the equation of that blue line if I put arrowheads on it? Well, some of you have a hard time with this. Look at this point here. That's the point 1, 2, 3, 1. That's the point 3, 1, right? What's this point right here? Well, that's the point 3, 1, 2, 3, 4. If I do one more point, say this one up here, I'm going to get 310. What do you notice about every single x coordinate? They're all identical. So the equation of this blue vertical line is x equals 3. So I like to use a vertical line, or you need to use a vertical line because it tells me x values. If I put it here, it's at x equals 1.5. Here, x equals 0, x equals -1, x equals -10. Okay, so the vertical line is to test for domain, and the horizontal line is a test for range. Now what I'm going to do is I'm going to move this vertical line across the x-axis and see where I'm hitting the graph. Ask myself, do I hit the graph when x is 0? I sure do. Do I hit it when x is a positive? Yep. Some of you are thinking, oh, you're not hitting it anymore, but you're not thinking. In fact, you know what? Let me do this just to further emphasize the point. Let me actually make it a line instead of a segment. Won't the black line that's a part of the graph and my blue line eventually intersect somewhere up here? So you see this blue line is going to hit the black line eventually. So all of these numbers are a part of my domain. They're all part of the input. How about if I go in the negative direction? Same thing. All the numbers are a part of the domain. So I say my domain is all real numbers. Okay. Now for my range, that's where I'm going to use my horizontal line, and I should put some arrowheads on it. Okay, so let me get this blue line out of the way, and I'm going to take this red line. I have a little trouble here. There we go. And I'm going to see, does it hit the graph everywhere? Well, no, it doesn't. Does it hit it when y is positive? Well, sometimes when y is positive, but there's values here that are positive from here to here, and the graph isn't going through those y values, is it? Right? Nor is it going through when y is 0 or below. Okay? So what's the vertex of this problem? Well, the vertex should be 0, 2, right? So the y value right there is 2. So it looks to me like the y value of this graph, any point on it, the y coordinate will be 2 or larger. So my range is going to be all real numbers such that y is greater than or equal to 2. All real numbers such that y is greater than or equal to 2. Okay? All right, let's test it out on this one. Here's the equation. I have the graph. Oop, I forgot to bring my testing lines with me. Let me get my oh no. Let me get my domain testing line. And now I need my range testing line. Bring them all down. There we go. All right, so let me move this out of the way. And let's see here. So my domain is I'm going to use this vertical line and see if there's ever a place that I won't hit the graph. And I don't think there is. Looks like I'm going to hit it everywhere. Okay, now of course you can use a ruler or a pencil to test it. but my domain in this case is going to be all real numbers. Okay? Now my range. I'm going to use my horizontal line to test, and it sure looks like if I go down here, eventually the black V will hit my red line. It's going to hit it, it's going to hit it, it's going to hit it, going to hit it, going to hit it, going to hit it, not going to hit it, right there. Okay, well, what are the coordinates of that vertex right there? That looks like is the point -2, 4. And since I'm talking about the y value, the output, the range, the y coordinate looks like it can be 4 or anything below 4, right? So I'm going to say it's all real numbers such that, that's what ST is, such that y is less than or equal to 4. It won't always be an equation, not always. You have to stop and consider the situation. Don't just try to memorize what I'm doing. All right, let's try another one. This one will be a slightly different. I don't know if you remember in class, we talked about how to get, briefly, how to get a V that would open left or right. And Dylan, I think it was Dylan, suggested the equation would be uh, x equals the absolute value of y. Is that right? Anyway, uh, yeah, that should be right. So I just had a mental blank there, pardon me. Uh, let's test our domain. And let's see, it looks like we're going to hit all the positives because out here it'll hit way up high, right? So it's going to hit all the positives, all the positives, all the positives. It's going to hit at 0, but it's not going to hit anything below 0. So the domain in this case will be all real numbers such that um, x is greater than or equal to 0. Okay, now we'll test the range. All right, so let me move this guy out of the way. And it looks like it's going to hit when y is positive. It's going to hit when y is negative. And it's going to hit when y is large negatives, or small negatives, I should say. So the range is going to be all real numbers such that, oh no, it's just going to be all real numbers, isn't it? Yeah, because every number on the y-axis is going to be included. All right, I'll tell you what, let me pause the video. I'm going to set up a strange one. Okay, there's a very strange graph. It's called a piecewise function. We won't graph anything like this. Don't ask me the equation that generated. I just made up the picture. But I did it because we can use our test to find domain and range. Okay, and on this strange one, it might be a little bit easier to understand what I'm doing with the domain and the range. I'm really worried that some people are going to assume, the range or the domain is always all real numbers, and it's simply not the case. Okay, I went and got my vertical and horizontal lines. Let me move them up a little bit so that we can use them. And I'll start with my domain, my x values. It looks like x can be really large positives, doesn't it? Okay, really large positives. It's like x cannot be 1. I'm going to make a little note of that over here. I'll say x cannot equal 1. All right, and then we're going to go here. Can x be -4? Well, up here it can't, but down here it sure can, so that's okay. And then x can be any other number. The only restriction is 1 right there. So here's how I write that. The domain is all real numbers such that x does not equal 1. So it's all the numbers on the number line except for 1. Very strange situation. That's more a pre-calc topic, but I thought it would help you understand that the domain and range are not always all real numbers, or one of them doesn't have to be all real numbers. Okay, now let's take a look at the range. And it looks like y cannot be very large positives. This graph, based on what it's doing, looks like it's going to flatten out and go linear here. Okay, so what is the largest value y can be? Well, I think it's 8. I think the largest value is 8 for my y coordinate. Okay, and I'm going to come down here. Oh, look at that. I've got a hole in the graph. There's no green in the graph here or anywhere in between or on either side, and that's at the value of 6. So I know that 8's the largest number. Okay, I know y is not allowed to be 6. And let's come down here. Oops. Let's see. It's okay. It's okay. It's okay. It's okay. It's okay. All right. Looks like the smallest value is going to be right here, and that's at what? -5. 1, 2, 3, 4, 5. Yes, that's at -5. So -5 is the boundary. So my range is going to be all real numbers such that x is between -5. It's allowed to equal it, so I'll put an equals there. Oh, y, I should have said not x. And 8, but y does not equal 6. So it's all the values from -5 to 8 except negative or except +6. There you go. All right. Or you could write it like this, except 6. That might make a little bit more sense to you. Okay, that's the video for this weekend. I hope you have a nice 4-day weekend, and I will talk to you later. Mr. Lawrence signing off. Have a good weekend, everybody.